Hello all. Today we are going to do limits of composite functions. This is a short little mini lesson on how to graphically analyze composite functions to find your limit. So I have a couple of things written here for you and a couple of things already highlighted. Pause the video as you need to. The limit of a composition is the composition of the limits provided the outside function is continuous at the limit of the inside function. Problems occur when f of x is not continuous at x equals L or the existence of the limit of g of x at x equals A. At issues of this sort, we can't apply the property. You might assume that the limit doesn't exist, but this may or may not be true. And then remember your definition of your limit. If the limit from the left is equal to the limit from the right, then the overall limit exists. So how you're going to do composition function limits is think in terms of how you get to your limit. Do you get to your limit from above or do you get to your limit from below? If you get to your limit from above, you will approach from the right. If you get to your limit from below, you will approach from your left. And you should see how all of that kind of comes into play. We're going to use a U-type substitution to mathematically find these limits. So we have the graph of f of x, and our problem is find the limit as x approaches 1 of f of x. So what we have to do here is look at our graph. When x approaches 1, our limit is -2. That is coming from above, from both sides. So that's from above, which will indicate from the right. So the u comes into play as a rewriting of our limit. U will equal the limit as x approaches 1 of f of x, which we just found, is -2. So that's step 1. Step 2 is to rewrite your limit so that you can find your composition limit. The limit as u approaches -2 from a positive direction of the f of u function, and then we look at our graph for that answer. -2 from the right is +4. Therefore, the limit as x approaches 1 of f of x is equal to 4. So again, walking you through example 1. Composition. As x approaches 1, what is the limit? As x approaches 1 from the left and from the right, the value is -2. From above, they both come from above, indicates from the right. Rewrite your limit. Limit as u approaches -2 from above of the new function. Looking at your graph, approaching -2 from the right, y value is +4. Every one of these problems is going to be done the same way. So if that was kind of confusing, hopefully by the time we're finished, you will have caught on. Looking at your graph, the limit as x approaches 0 of f of x. So looking at 0, we get 3. So u equals the limit as x approaches 0 of f of x is equal to 3. Now, to get to this limit, you came from above and from below. That just means you set up two limits. the limit as x approaches 3 above from the right, and the limit as x approaches 3 from the left. So 3 from the right is 1, and from the left is 3. Therefore, the limit as x approaches 0 of the composite function does not exist. Now I want you to think to yourself, why does that limit not exist? You're approaching two different y values from the left and from the right. The problems on the back of this page or on the next page, however you chose to print them out, is going to deal with three different graphs, f of x, g of x, and h of x. We're still doing the same thing. Number 3, the limit as x approaches 1 of f of x. So we're just dealing with graph number 1 here. So the limit as x approaches 1 is negative 3. To get there, you came from above. So that indicates you're positive. So your limit as x approaches negative 3 from above of your function, negative 3 from the right is positive 2. Therefore, the limit as x approaches 1 of f of x is equal to 2. Notice even at the end how you write your answer. All right, now we're going to look at some composite functions using different graphs. So you always start on the inside and work your way out. So as we look here at example number 4, the limit as x approaches 2 of h of g of x. We're going to start with u being the limit as x approaches 2 of g of x. 2, the limit as x approaches 2 of g of x. So we have two different y values. So this would be approaching 3 from below, and also 1 from below. Two different y values gets two different limits. So the limit as u approaches 3 from below of the function, and the limit as u approaches 1 from below of the function. And let me make a correction here. This should be u, not x. So f approaching 3 from a negative direction. 1, 2, 3 from a negative direction. I'm sorry, that should be h. I was wondering why my answer key is wrong. H. 3 from a negative direction. 3 from a negative direction is 4. And 1 from a negative direction also 4. Therefore, the limit as x approaches 2 of h of g of x is equal to 4. So I'm going to redo part of that, not writing it down, but just going through it to make sure we got everything. H of g of x, we start with x approaching 2 on g of x. We have two different y values. From below, from the left gets 3. From the right, from below gets 1. So 3 and 1 from below. So 3 and 1 from below. Then we go to the h function approaching 3 from the left. H function approaching 3 from the left is positive 4. H function approaching 1 from the left, positive 4. And because those are the same, 4 is your overall limit. If you would like to pause this video and try example 5 by yourself, you're welcome to do so. U is equal to the limit as x approaches -1 of h of x. Approaching -1 is -4. You get there from above. One value because they approach the same value. So the limit as u approaches -4 from above, g of u, -4 from the right, -4 from the right is -3. All right, a couple more problems here on the last page, examples 6 through 9. Problem number 6, u will equal the limit as x approaches -3 of that interior function g of x. -3 would be -4 from above. So the limit as u approaches -4 from above of the outer function. -4 from the right is -1. Therefore, the limit as x approaches -3 of f of g of x is -1. Example number 7, u is equal to the limit as x approaches 2 of the inner function g of x. X approaches 2 from the left and from the right would be 4 from below. The limit as u approaches 4 from below of the outer function f. 4 from the left would be 3. Therefore, the limit as x approaches 2 of f of g of x is equal to 3. Pretty straightforward problems there, 6 and 7. Little different here for 8 and 9. Limit as x approaches 2 from the right of f of 8 minus x squared. So the first thing we're going to do is make u be 8 minus x squared. And we're going to do a little sketch here of what that looks like. If you don't know what that looks like, just take your calculator and graph it. Downward facing parabola, y-intercept of 0, 8. And then we need to know what's happening at 2. It is a continuous function. We need to know what is happening 2 from the right. So 2 from the right, we're going to go to second window and go to our chart 2, 4. So the point 2, 4 is going to be here. So as x approaches 2 from the right, and really the left too, but we're focusing on the right, u is going to approach 4. it's going to approach 4 from below. So the limit as u approaches 4 from the left of your function, 4, and we're going to our f here, 4 from the left, 4 from the left is 3. Therefore, the limit as x approaches 2 from the right of f of 8 minus x squared is equal to 3. So you have to do the algebraic work in order to figure out your limit value as x approaches. Then go to your graph to get your limit. Example number 9 is a sum function with the graph on the inside. So we're going to break that up as the limit as x approaches -4 from the right of 2 plus the limit as x approaches -4 from the right of f of x. So that's where we start. We're going to break that inner part up. This is just 2 plus, go to your f graph approaching -4 from the right. -4 from the right is -1, which equals 1. Set up your new limit as u approaches 1, and we came from above. G of u. So g approaching 1 would be 2. Therefore, the limit as x approaches -4 from the right, g of 2 plus f of x is equal to 2. And that concludes our notes on limits of composite functions. I hope you guys have a good afternoon, and let me know if you have any questions.